Alright, here's the video for chapter 9 section 0 and 1. So we're talking about transport layer. Transport layer is layer above layer 3 or networking layer. This is layer 4. This job is to complement networking layer to get your stuff done. We're talking about the multiplexing and segmentation that it uses. So the role, as I said, internet or networking layer, we're using the TCP/IP model here, is what allows the application internet parts to work together. They had different responsibilities, and we're going to talk about that responsibility. So the transport layer takes care of the individual conversations. So for example, your PC, you might be watching a video and doing homework, maybe chatting with your friends, and TCP, or the transport layer, is what is responsible for keeping track of what piece of information goes to which activity. So we have the brown here are all the streaming video, you have the purple here, which is your instant messaging, and the web pages are your orange and yellow. And as you see here, they intersperse between each other based on how much you have. This is called segmentation. Basically, it's breaking down the chunk of data into smaller parts so it can be sent in groupings. Now, how does this happen? Oh, sorry, I'm getting ahead of myself here. Well, it's called multiplexing, which is allows multiple communication streams. The segmentation is breaking apart, and error checking is still done. Here we go. There's two protocols, TCP and UDP. As you can see, these TCP lines up with these upper layer application protocols, and UDP with these. They have certain purposes. They have certain specific attributes that we're going to talk about. TCP is a more reliable one. It's basically sending a package with requiring the post office to get a signature for it. So in this case, they'll send 6 segments total, 3 at one time, get a reply back saying, yes, I got all 3, and send me the other 3. Then they'll go and do so. It acknowledges the data sent, so you know you get all the data, not just some of it. UDP is different. It's much faster because it does not acknowledge the data sent. It just waits for it to happen, gets it there, loads it, and that's it. So if you don't get it there, well, then you don't get it there. TCP is used for stuff where you need to know you get it, like your web pages, your emails. This video you're watching is on TCP. UDP is something where speed matters. You're on the phone. You're watching a video. Live video. So you're taking a class. That'd be a live video. In this case, you're not using the UDP, you're using TCP because it's the recorded video. If this was a live class, then it'd be UDP. So my TV students are on UDP, unlike you guys. TCP services. You have web pages, it's messaging, it has an established connection, knows there's someone on the other end, and back and forth. It's reliable. You make sure you get the stuff in the right order, roughly. If sometimes on your text messages might have timestamps wrong on occasion. Ain't perfect. That's life. And then flow control, basically the rate of the data being sent. The data is so much more complicated than UDP. There's a lot of more portions to it. It takes a little more space. UDP is very fast. It sends it as it sends it. If there's a hiccup in the connection, you might get some later than the other one. So you might get some weird artifacts when you're watching videos sometimes. Deliveries, no guarantee. He doesn't necessarily know there's anything on the other end. There's no control over this stuff. And again, the opposite here. That data packet is much, much smaller and simpler. Again, there's trade-offs. Now, that explains what the protocols do. We talk about multiplexing. Multiplexing allows your device to do multiple things. How does it know what data streams for what? Well, we use something called ports. No, this is not the physical port on your PC. These are the same word. I really wish they didn't do this, but for some reason it did. This is more like a pier. You're both coming into the harbor. What pier are you going to be at? Some piers are for shipping, some are for passengers. In this case, port 110 is set is for electronic mail. HTML web pages is port 80. HTTPS, the secure version, is 443. Internet chat IRC is 531. These are defined. And so it sends these on the port numbers. So it knows. These are paired up with the port sent from. Destinations to, sources from. They're called socket pairs, so they know if there's a stream of communication back and forth, it knows who to reply to. So yes, I got the first 3 packets, I sent it back to 1305 port at the such and such IP address. Now some port numbers are well known. Basically they're already given out to somebody, you can share them. Registered ports are not quite as well known, but they're pretty close. And then these are the ones that change repeatedly. So if you have multiple streams that don't fall in these categories, those are where they go to. These are set. And in many cases, you kind of have to memorize these, what they do. So 2021 is FTP. It also tells you the protocol type, or TCP or UDP. DNS is 53 on both UDP and TCP. UDP 161 is for SMP. You know, these are set. Net status is a command used on your PC in order to look at what protocols are being used on your PC. So if you're curious, if you have a bunch of protocols running, maybe you think you're getting hacked and turned into a botnet, this might be one of the skills, the commands used to hunt that down. Go ahead and use this activity. Compare the types. This is important because they are very, very different from each other. You need to make sure you have that. I'm going to stop here and I'll do the next session, 9.2, a little bit.